Hi, everybody. Welcome back to the Shuko Math Practice Lab, Learning Through Practicing. It's so nice to get the chance to work with you again. So today we are going to work on the limits, this unit again, on the practice set number 2. And in this practice set, we're going to talk about how to find the indefinite limits and the associated asymptotes about it. And so those are we have a total 11 problems we're going to work on, and but those are pretty simple problems here. And so just want to give you some idea how to find the indefinite limits. That means, if your limits going to the infinity and or not exist, how do we find it? Okay, as always, try to do those problems by yourself first, and to see and how many you can get it, and then later you can come back here and we can check the answers. Okay, so now if you want, you can pause the video and then try to do some problems by yourself. And I'm going to the whiteboard now, and so when you are ready, just go to meet me in the whiteboard. Okay. Hi, everybody. I'm at the whiteboard. And so I hope you got a chance to do some of the problems I listed there. So let's try to check the answers. As always, I like to do a very brief review and some of the key elements you might need to use for this set of the homework. So the first is here, I just want to let you know, when we have when we have the top is the numerator, if it's a constant, and if it's the denominators here, right? So if the denominator is kind of going to the, become the infinities here, right? So then these ones here, we know this one will give what? Will give zeros, right? So now, how about if I have some constants here? So if my denominator goes to 0, then I know these ones here will going to where? Going to the infinities here. But also in here, we need to be careful because on the practice set, number 1, we said that, when you find the limit, we can find through the left-hand side or right-hand side. So in here, I want to put the notations here. So if you have the 0 to the negative, so this is not a really good notation, but basically is try to tell you here is if my denominators, right, is approaching to 0 from the left-hand side, that means the values here on the denominator is negative, and it will become smaller and smaller, will be bigger and bigger, but it's closer and closer to 0, but it still is negative. So for these ones here, right, then we need to know the limit going to approach to the negative infinity. All right, so the same way is here, if you approach here, if you approach from the right-hand side here, right? If you approach from the right-hand side, that means the denominator, the value always would be positive, but it's getting smaller and smaller to 0. So that means this number is going to approach to the positive infinities here. So I just want you guys to remember here, and then also the value make the denominator equal, the approach to 0. That's what we call this, the vertical asymptotes, right? You guys still should remember this from the algebra 2, right? If the denominator equal to 0, that's value. Of course, you cannot factor that out, and then we become wholes, right? And that value is, we call it vertical asymptote. Okay, now let's take a look at the problem. Let's start to do, we have 11 problems. So let's start to do this, okay? So here, this is a limit x approach to 5, right? To the, I said positive, that means from the right-hand side here. So this is x plus 1, x minus 5. Okay, so in here, as you can see, the x approach to 5 from the right hand side, this number going to approach to 6, right? And but what happened to here? This number, because I'm approaching from the right hand side of the 5, so this one will approach to 0, but it's always greater than 0, right? So that's why the limits here, it will be what? According to what I put here, this will be what? Will be to the infinities here. Correct? Okay, so now let's take a look at part B here. The part B, I have a limit. This is x approach to 5 from the left-hand side over the negative. So here, this is x plus 1, and this is x minus 5 here. So for these problems here, the top here, when x equal to approach to 5 from the left-hand side, this number is still going to approach to 6. But what happens here? What happened to here? Okay, so here, this is x minus 5 will approach to 0. Better x is from left-hand side. So x is always less than 5, right? So that's what means you're going to have a always is negative number, but it's very good, close to 0. So what is the limits here? The limit will be what? Approach to the negative infinities here. All right. So now let's do part C here. The problem C is here. The problem C is this is limit x approach to 1. Then this is 2 minus x, and this is x minus 1 to the square. So let's take a look here. The first one here, when x approach to 1. So what is the top approach to? Approach to 1, right? 2 minus 1 is 1. Okay, so now let's take a look here. X minus 1, right? So when x is getting closer and closer to 1, here, as you see, it does not have the from right-hand side or left-hand side because it doesn't matter, right? Why it doesn't matter? Because here I have x squared. Right, so x minus 1, either from right-hand side or left-hand side, if when you square it, this is always what? This is always become a positive, I say it's a positive 0, that's a bad term, but it's kind of a approach to 0, always be the positive numbers, right? So because of the square, so what happens here? So this will be the positive infinities here. Okay, let's take a look at part D here. So this one is, those part is kind of pretty easy, but this will, like I said, this unit is a foundation, and you need to be good at it. And later we're going to dealing with limit. We still have a lot of things we can, you need to use the limit, so we need to be very good at it. Okay, so now here, x approach to 3 from the left-hand side here, right? So what is this number approach to? This number approach to the square root of the 3, so it's a constant. Okay, so now let's take a look. X approach to 3 from the left-hand side. That means x is less than 3. So if x is less than 3, you minus 3 going to have what? A negative number. So the negative number, you fifth power it, still is negative. So what happens here? So the bottom will be the 0 negative. That means it's always be negative, but getting closer and closer to 0. Okay, so one more time. So what is the limit here? It's negative infinities here. All right. Okay, so now let's take a look at part E here. The part E, we have, this is limit, right? So this is limit x approach to 3, the positive sign. Then this is natural log x squared minus 9. Okay, so think about it, right? So when the x squared, when the x squared and the x is from the right-hand side, that means x squared is what? Is always greater than 9, right? So the x squared is always greater than 9, so minus 9. So what is this numbers going to approach to? Approach to 0, but it's always be positive because you have, greater than 9. Then in here, we know this is my natural log function, correct? This is what the natural log function going. So when the natural log getting closer and closer to 0, what happens here? This one is negative infinities here. All right. So now let's take a look at part F here. The part F is here. This is the limit x approach to 0 from the right-hand side. And this is natural log sine x here. All right. So now I know the sine function is like this, right? So when the sine, okay, x approach to 0 here, that means you approach to 0, the sine will getting closer and closer to 0. But what is this one getting closer to 0? It's close to 0, but it's positive values, right? So it's closer and closer to 0. And then the natural logs, again, when they're close to 0 is what? It's negative what? Infinities here, right? So like in here, for example, like the part F, this problem, if they say x approach to 0 from the left-hand side, then the limit does not exist because I know the natural log cannot have negative values there, right? The domain of the natural log has to be positive here. Okay, very good. We are progressing very well. That's excellent. Let's see here, part G is here. Okay, so this is a limit, right? So this is x approach to 2 pi from the left-hand side, x cosecant x is here, okay? So let's take a look. When the x approach to the 2 pi from left-hand side, then this number will become a constant, right? Will approach to 2 pi here. Let's take a look at cosecant x is here. If you still remember the cosecant x, so that's why it's kind of like you need to know your trig functions, right? So this is okay. So this is a pi. This is a 2 pi. So this is a cosecant functions, right? So here, okay. So now they say the cosecant x is the approach to 2 pi from the left-hand side. That means I'm approaching to from here, right? From the left-hand side of the 2 pi. That means this value is going to where? Going to, right? So the whole cosecant x is going to what? It's negative infinities, correct? So the negative infinity times the constants. So what is here? This will be the negative infinities here. All right. Okay, so now let's take a look. Part B, C, D, E, F, G. Okay, H is here. Okay, so the H here is this is a limit x approach to 2 from the left-hand side. And this is x squared minus 4x plus 4. And this is x squared minus 2x here. All right. So like in here, we said, okay, this one's here. We always plug in first, right? When we plug in, we see it is 0 over zeros, right? Okay, so now let's take a look. This is limit x approach to 2. Here, I can factor this one out a little bit, right? So this is x. Then this one here is x minus 2 to the what? This is x minus 2 to the square. Ha. What I see here, oh, boom, I can cancel 1 here, right? So this will give me limit x approach to 2 from the left-hand side, x minus 2 to the x. Okay, so let's take a look at what happened to the numerator. This will approach to 2, approach to a constant here. Okay, now from here, here they say is approach to 2 from the left-hand side. That means the x value is always less than 2. So what is this number approach to here? Is approach to 0 from the left-hand side. Okay, so from 0 to the left-hand side, what is the limits here? Negative infinities, right? Okay, now let's take a look. Next one here. This is limit x approach to 2 from the right-hand side. And this is x squared minus 2x minus 8. Then this is x squared minus 5x plus 6. Okay, so let's simplify it a little bit. X approach to the 2 from the right hand side. Let's try to factor. Okay, so this will be x minus 4, x plus 2, correct? Okay, so the bottom will be x minus 2, x minus 3, right? Okay, so now let's take a look. When the x approach to 2, this one will approach to what? This one will approach to negative 2. This one will approach to what? This one will approach to 4, right? So the top basically will approach to negative 8. Okay, now let's take a look at bottoms here. The bottom, if x approach to 2 from the right-hand side, what is this number going to approach to? This going to approach to some positive numbers, right? Will approach to 0, to the kind of positive number. Then what happened to these numbers here? When x approach to 2, this one will approach to negative 1s here, right? Okay, so now let's see what is the limit here. So I know when this is approach to positive, so this will be the infinity. But then I have a 2, see here, I have a 2 negative here, negative, negative. So the whole things here, the limit will become to what? Positive infinities here, right? Okay, so this is kind of a pretty important. You need to check, right, to see the infinities here. Okay, so like a positive negatives here. Okay, so let's do ij. Okay, so this is the limit x approach to 0 from the right hand side. This is 1 over x minus natural log x. See here. Okay, so be very careful. When x approach to 0 from the right hand side, that means this number approach to the 0 from the right hand side, this number approach to the 0 from the right hand side, right? So let's see what happens here. So 1 over x, when you approach to 0 from the right hand side, this will be positive infinity. Then minus natural log, remember we just did the graph here, natural log is this graph, right? So when it's approach to 0 from the right hand side, what happened here? It will approach to negative infinity. So this will be infinity plus infinity. Oh, I definitely know the infinity plus infinity is infinity. Okay, be careful here, right? So be careful. So here, that's what I want to say, be careful. If I have an infinity minus infinity, then I don't know what is this, right? Okay, so this is what we're going to wait when we, in the L'Hopital's rule unit, we're going to take care of this one. But infinity plus infinity definitely is infinities, right? Because they, they go very, they both go to infinities here. Okay, so last one, okay, let's take a look at last ones here. Last problem here. And so this is the limit. Okay, so this is x approach to 0. And this is a natural log x squared and minus x negative 2. Okay, so let's take a look at these ones here. So this is limit x approach to 0. Then this is a natural log x squared. I can put this one on the denominator, right? So the first things here, and you will see, hey, here, I don't have approach to the right-hand side or left-hand side. Well, it doesn't matter because why? Because both my functions here have x squares, right? So even you approach from the right-hand side of the 0 or you approach from left-hand side of 0, they both will be positives, right? So that's why both of these going to approach to the positives, from the 0. Okay, so now let's take a look. Again, natural log 0, when the approach to 0 is what? Is negative infinity. Then minus, what is 1 over 0 to the positive? It's positive, right? So infinity. Oh, so here, negative infinity minus negative infinity, or you can treat as is negative infinity plus negative infinities, right? So the negative infinity plus negative infinity, of course, going to go to the negative infinity. So that will be the limits here. All right. So that's why in here, all like, for example, the asymptote is associated with those indefinite limiters here. Okay. So like the asymptotes here is x equal to 5, and the asymptotes here is x equal to 0s. And so you can see that that's what is the indefinite limits here. All right, so this practice set is pretty simple, but it's a kind of very important to set your foundation, because later, the problem going to get a kind of little tedious. So you need to have very clear mind, right? So when I go to indefinite limits, it's going to the positive or negative infinities. All right, so I'm glad we'll be able to work on this practice set, and hope you got all the answers correct, and then I will be very happy. But anyways, here, remember, practicing, practicing, practicing. That's the way you will make your math getting better. So here, I'm so happy to talk to you today, and looking forward for you to come to visit my next video. We're going to talk about how to find the limits. If you have a very special function, we talk about step functions or piecewise functions. So how do we find the limits here? Okay, nice talk to you, and you have a good day and work hard. Okay, and looking forward to um, to meet you in our next videos here. Okay, goodbye. Okay, have a good day. Bye.